What's up, 7th graders? It's Mrs. Talati.
And Mrs. Cervantes.
And together we are
Mrs. Cervati.
Hey, so we're going to quickly cover part 2 today, which is distributive property and factoring. It's going to
louder.
It's going to go back into algebraic expressions where then we do combine like terms, but we got to get to that point first. So the first I'm going to head over to Cervantes because she did cover distributive property a little bit in the last note taker.
Yeah, so think back. We went over distributive property. I talked about how if I hand Miss Talati a stack of papers and I say, can you distribute these to the class, what's she really going to do? She's going to hand out a paper to each of the members in the class, each student in the class. So when you're looking at distributive property, like you are here, you are looking at A times B plus C. So you're looking at what we call a binomial in the center. A times B plus C, multiplication, reminder, next to the parentheses means multiplication. So it's A times B plus C. What that really turns into is A times B plus A times C. So what you're really doing is you're handing out this A to everything inside. And when we say handing out, it means you're multiplying it. So A times B gives you your A times B there, plus your plus here, and then A times C here. So it's AB plus AC. If you're looking at A times B minus C, the only difference is you're looking at a subtraction of the variables in the middle, B minus C. You're still handing out the A to everything inside. So A times B, and then you have minus, and then you have your A, hand out your A to your C, A times C. So what that looks like possibly with numbers, we could do, let's just do easy, 2x plus 3. What that would look like is I need to hand out, distribute my 2 to everything inside. The first one would be a 2x, 2 times x, and then a 2 times a positive 3, the plus 3. So 2 times 3 is 6. So your answer would be the expression 2x plus 6. And then remember, you can't put 2x and 6 together because they are not like terms, okay?
All right, and then factor, you guys, God, do they do factor trees in like 3rd or 4th grade? I want to say they start like factoring numbers, right? So when I say a tree, I'll just use the example that I gave here. If we look at the number 21, what are the factors of 21? 7 and 3, and then these are prime numbers. Maybe I should give one like 24 since it's got more terms. So maybe let's start with, let's say 4 times 6. These are both composite, so then I break it down, 2 times 2, 2 times 3. So these are factors of 24. So that's kind of what we're going to look at in the second part of 6.1 is factoring. All right.
Okay, so looking at distributive, we're just going to practice. So you see that they gave you the lines up here. I just used the little rainbow looking one so that I don't forget to hand out that 8 to everything inside. So an 8 times a 4x plus 3 would be an 8 times 4x. So you can write it out if you want to all the way, plus an 8 times 3. And then you can do the computation. So 8 times 4x, remember with multiplication, you don't have to have like terms. You can go ahead and multiply, plus, and then 8 times 3 is 24. 32x and 24 do not have like terms, so it stays that expression. You can't add them together. And then negative 4 times 9x minus 3y. So be careful and go slow, you have negative signs. So you have negative 4 times 9x, and then you have, you have minus, and then you have a negative 4 times 3, which is negative 12y. Okay, so you have to add the opposite, and then negative 4 times 9x is negative 36x and a 12y. But x and y are not like terms. They're not the same variable raised to the same power, so that's as far as you can go with that one, okay? If you're looking at this too, some of you might want to just say that that's negative 3y, so you automatically would know that's positive 12. You can write it out either way, it's fine.
But we do want to see, we want to see that middle step, so do not go from the actual problem to the answer. You guys will make many mistakes when it comes to positive and negative signs.
She's saying we want you guys to write out that part of the expression
however you do it.
Yeah,
so if you do it like Cervantes did, the negative 4 times the 9x, or where you do the computation there, show us what you're doing.
All right, and then distribute your negative 3 again. So negative 3 times 4x, negative 3 times positive 2y is negative 6y, and negative 3 times negative 6 is positive 18. And then the only computation I need to do here is my multiplication, so negative 12x minus 6y plus 18. And if you look at each term, remember we're using vocabulary, if you look at each term, none of them are like terms, so you're done, and that's the expression you keep as your answer, okay? So they don't always solve all the way down like you guys are thinking.
And these are pretty basic, so just know that you guys know when we get into class that we're going to have to give you some problems that are a little bit more complex and maybe have more steps involved. Okay, what do we got here? Man, that's so terrible. Both you guys, both of us are like squinting the board like, can I even see this? Yeah.
This is in your book if you want to have your book next to you too.
And I think their note taker's a little bit better. Mark is selling tickets for a high school band concert. The band gets to keep 25% of the money he collects from ticket sales to put towards new uniforms. Write an expression to represent how much the band gets to keep. So let A represent the number of adult tickets he sells. You guys, I gotta grab the book. I can't even read what the ticket prices are.
It writes it out for him. $16.60.
But isn't there's a step in between because he buys multiple tickets, isn't it?
No.
Or is
it's
it, oh,
just
it's 20%.
$16.60A.
But it's 20% of. You see what I'm saying? So this is going to be kind of a complex one because they're going to
So
have to
it's
turn that to
0.20 times
times.
1660A
Yeah.
plus 0.20 times 1220Y.
See, and that's funny because this
They just need to write it out.
Oh, it's 25%. Okay.
Yeah. Oh, yeah. They just have to. You guys just write this one all the way out.
So we're going to remind you that 25% is really 0.25, right? And what they're saying is 25% of all of the money that he sells. So they give the expression here, but now we have to identify that it's 0.25% of, remember of in math means to multiply, plus 12.20y. So then here, do they have to solve it all the way out in this?
Yeah, they have to distribute it, and they just write it all the way out.
Okay, so then we get 0.25. So again, if we write this middle step, we get a 0.25 times 1660.
Which is
plus
$4.15A.
What is it?
$4.15 A.
Perfect. And then we have the 0.25 times the $12.20 Y. Oh, I forgot the A here. Thank you. And how much is that one?
$3.05.
Now listen, we're giving you the answers, but if you guys were to take the 1660 and multiply it by the 2.5, you're going to get that solution right there, okay? So then it would be $4.15 per the adult ticket and $3.05 proceeds go towards the youth ticket. Okay, we're going to jam because I got to go get my kids. Oh, golly. Okay.
Is this practice? Oh, no.
No. So if you guys look, whatever your smallest term is, that's the one you want to identify if you can pull from the other. So if I look at my 2x, that's smaller than 16, right? Is 16 divisible by 2? So if I look at these, I can divide both terms by 2, right? Which means I'm going to pull out a 2. This seems to be the step they always forget, right?
Well, and like the way I was saying it to one group was undistribute. We're going backwards.
Backwards, good.
You're undistributing. Distributing, you go forward. In factoring, you're going backwards. So then how you would check your answer, so how Ms. Talati would check this is to use the distributive property and see if she gets back to 2x plus 16.
And see how this answer matches this answer. But it seems to be whatever you divide by or whatever you factor out, like if I look at this one, I'm going to factor out a 3, right?
Your GCF, yeah.
Yeah, your GCF,
greatest common factor
has to come out of the equation. So then the answer for this one is just the 3 times the x plus 4. And again, if I go through and double check this, I get 3x plus 3 times 4, which checks out to be the problem that I started with.
Yeah. So I think the key here is making sure you go back and check it.
Yeah.
You're undistributing and then distribute back to make sure it matches.
So those cancel out, x plus 7. Then I want to make sure that my answer is right. 5 times x plus 5 times 7, 5x plus 35, and that checked out. So my answer is actually that second step.
Yep.
Okay?
Perfect.
Give it a shot. Now these are going to be a little bit more difficult. Do not stop because you have decimals and fractions. You guys know how to find 2/3 of 6. Remember, it's just 2/3 times 6 over 1. You multiply straight across and reduce. So please do not forget that you know how to do these things. Okay? So of all the additional practice, have a great weekend. Bye.